In today's demonstration, we'll take a look at building scope configurations using validated content for networks. We'll try to answer those existential questions like, not why are we here, but where are the Ansible examples located, and what's the prescriptive viewpoint from the vendors? In order to understand validated content, we must first understand the value of certified content. Effectively, certified content is necessary, and we must select the proper content when we know what we want to automate. So if we're automating Cisco routers, then we need Cisco router certified content. Certified content is delivered in a collection, and we'll speak here momentarily about what a collection actually is and what composes a collection. But before that, we need to understand just at a high level the value of certified content and what it's doing. So effectively, certified content is giving us a way to provide established integrations between Red Hat and third-party platforms in order for us to automate. And we want to do that in a trusted and certified way that provides vigor around testing and also support. So if you have issues with particular content, you can open up tickets with Red Hat, and Red Hat would provide that front end of triage that will help accelerate the process of determining the root cause of the issue or bug and resolving that so that you can move forward onward into your automation. And all of this content, certified content and validated content, is available through console.redhat.com. Collections are a directory structure containing the automation content. And key to this ecosystem of certified content are the modules. So the modules are typically built in Python for network modules, and they provide you with a consistent set of modules that you'll see in multi-vendor situations. There's consistency so that you can normalize the way that you automate. So you'll expect to find these particular types of modules. So the first one being the facts module, where it can go out and gather facts on the existing configuration state or the operation state of things like routers, switches, load balancers, firewalls, etc. They also include command modules because this is a way of you providing triage for things like troubleshooting. So, like you could send out show commands, and then those responses would come back, and you can use that as logic for your playbooks. Config modules give you a mechanism for leveraging Jinja 2 templates. So you can source a Jinja 2 template and push a configuration into your device, which is very common and a very popular way of implementing automation. However, we have resource modules now, and you'll see that resource modules are effectively our secret sauce because it provides additional layers of abstraction, additional state components, and the ability to provide scoped configurations. So scope configurations is a part of this demonstration, so we'll table this for now, but we'll definitely double click into resource modules here in a bit. Other things you'll find in a typical collection for certified content are example playbooks, example roles. So a role typically is made to be repeatable and focuses on a use case. However, these roles are not as advanced as what we're going to discuss here shortly with validated content and the roles that they provide. Plugins are things like inventory plugins for dynamic inventories, callback plugins to tabulate how long it takes to run a task, those types of things, and documentation that's needed so that you understand how to use the module and the structured data that needs to be passed into a particular module, and then testing. So testing is very important again because of the rigor and the ability to provide that security, that quality, and that reliability that certified collections and content provide us. Ansible validated content, which is also comprised of a collection, but this time it answers the question, how should I automate? So in other words, it's a role, and this role is very intelligent and it's very prescriptive. So this provides an opinionated path for performing operations on Red Hat and third-party platforms. In today's demonstration, we're going to look at Red Hat validated content for networking, but there's also validated content that is being delivered from our ecosystem partners that's specific to their proprietary solutions, whereas Red Hat networking is more around multi-vendor and how we treat these systems with consistency and normalize them through the validated content. So with this, and just like we mentioned previously with the certified content, it's tested and vetted. So that way, again, it introduces the opportunity to provide security, quality, and reliability. And it too is available through the Automation Hub on console.redhat.com. For validated content, the collection contents would include the following. This time we will not see modules, but we will see roles. However, we will see some playbook examples. In some cases, there could be plugins depending on what the use case is for the validated content. For example, event-driven Ansible often has custom source plugins that are provided as part of that validated content. There's documentation, there's testing, and then the roles. So these roles are more advanced, and again, they map to a particular use case or use cases, which require particular dependencies. So depending on the use case selected, there could be other certified collections that we need access to the various modules that are part of that certified content. So there's a dependency for those to be installed into our execution environments, as well as these roles can map to other roles. So other validated roles have a more defined scope. So if we look at network base, its focus is on multi-vendor across basic network configurations. But as we double click and drill into specific protocols like access control lists, BGP interfaces, VPN, OSPF, and others, then there's a dependency for network base, but then we also have to call the other roles. So the validated content is intelligent in the sense that it would map all those roles for us, and it provides a layer of abstraction to make it easy for us to provide that use case without building very complex playbooks at all. And you'll see that in the demonstration.
What do you do here exactly?
Whatever I want.
How did you get this job?
It's all, networking.
So this persist.yaml playbook is in our demo repository. And what we're doing here is we want to create configuration files by ingesting them from brownfield devices. So these devices haven't been previously automated. So by using the validated network content, the network.base, we're able to convert these into YAML files. So the way that this works is we're not only going to read from a project, we also want to publish to or back to the Git repository. So initially we clone them into our execution environment, and then we make the changes using the resource_manager role. So we're including this role, and then after the change, and the change being creating these files into the repository, we want to publish them back into the repo. So in Persist, this is the only one where we're writing files. So this is the only time you'll see this this Ansible.scm.get_publish module being used, and that's because we're writing files. So the files that we're writing equal these resource modules. So we've listed them out as variables. So each one of these represents a specific configuration, a scoped configuration for the network devices, and then the operation of persist does just that. Gathers the configurations, converts them into individual files, and saves them as host vars, in this case into our repository. So what we're doing here is we're saving them initially into the EE, so that's the local data store, and then they're being published into the repo. And then from that, we can deploy changes and manipulate these files, and we're fully ready for automation. To the left, we have our Git repo, and to the right, we have our persist.yaml job template. Let's go ahead and launch that one. We're gathering facts from the routers. The resource manager role is creating the host vars folder so that we can save each YAML file that maps to each resource module. Upon saving the YAML files locally on the EE, we need to push them remotely to the Git repo, the host vars directory, and each one of the YAML file directories. And that's what we have to the left here. So now that we've ingested the configurations from the 4 routers and converted them to YAML files that map to the resource modules, we are ready to automate. So we're going from brownfield into a net new environment to automate. Deploy.yaml is much simpler because we are not writing files to the repo. We are simply pulling them down, consuming those files to use in our playbooks that are a part of our role. In this case, it's the network.bgp run role. We have some required variables to set. In this case, we have to set the operation. So it's deploy this time as opposed to persist where we were writing files. Deploy allows us to merge configuration changes. And then finally, we have a data store. So we have access to the local playbook directory by default. So that's where our host vars is currently set, so we can access those files for each one of our routers. This role has access to BGP Global and BGP address family. Let's access the BGP address family for router 2 and add a new prefix. We'll add 192.168.4.4, and we need to save it. And we also need to commit it and push it to our Git repo, so that way it's available for our subsequent playbook runs. And then just to check to make sure that the change is in router 2, we'll take a look at it from the repo, the BGP address family, and we can see that we do have 192.168.4.4/32 ready to go. So from that simple playbook, we can run our job template and see how the validated content does all the heavy lifting for us. So running through and the results, standard output, and now let's see what has changed. And it should just be on router 2. Let's go ahead and drill into router 2. These are the commands that were sent to the router as serialized data on the back end from the Python scripts in the module. And then we have our before state. So as we scroll down, we can see the existing prefixes. And we have 2.2 where it stops. And then in the after, we should have our 4.4. And we do. So the change is true, and we can go ahead and validate that on the actual router. So in case you have trust issues, let's log into the router and ensure that we have 192.168.4.4 as a new network prefix, and we do. In this example, we have Bob logging in directly to add a new network prefix of 192.168.3.3, and of course Bob makes a mistake. That's 3.4, Bob, but no worries, we'll figure it out with detect. So by changing our simple playbook to the operation of detect, we can provide configuration drift. Configuration drift will run in check mode, and it will utilize the state of override to determine which configuration should be there or actually be removed from the device based off of our single source of truth, which are the YAML files that are stored in our host vars directory that we created earlier with the operations of persist. Now let's run our detect job template and find Bob's mistake. If we have configuration drift, we should see it changed. So let's go ahead and look at the changed. We run detect in check mode. So what you see here from the command lines is something that what we would actually need to change, but at this point in time, we're not executing the change. So we'll take a look at the before, and as we scroll down, we can see that we have that mistake from Bob, the 3.4. And the after will also include that because we didn't actually change it. So that's indicative of a check mode. See here, no change on router 1. So we have a quick pep talk with Bob, and we explain to him how easy that we can actually make the changes to the routers using Ansible automation and validated content, and also remediate all of the mistakes. Let's go ahead and fix this YAML configuration file by adding the 3.3 prefix. So we need to save that change and commit it and push it into our Git repository so that we can use it on the subsequent playbook that we're going to run the remediate operation against. With this playbook, we simply need to change the operation to remediate, and then that will allow us to use the state of overridden to override any changes that are not in our current YAML configurations that are stored in our host vars. So let's go ahead and run the remediate job template and see if we were able to successfully fix Bob's errors. Okay, let's see what changed. On router 1. So we look here, we see those commands again from detect, and we'll go ahead and examine our before, which shows us the mistake. There's Bob's mistake. And then we'll go ahead and scroll down to the after, but this time you'll note that only the correct prefixes there. So we removed the error and we added the configuration that we committed into our repository. Well, I hope you enjoyed this demonstration and you saw the value of using validated content to make it easy to simplify our playbooks and for intelligent roles to do all the heavy lifting for us behind the scenes. I also wanted to leave behind with you the repo from today's demonstration, and I look forward to seeing you on the next demo. Take it easy.